नमस्कार विद्यार्थी मित्रो, मी सचिन पाटील. कॉम्पिटेटिव्ह वेब पोटेन्शियल टू अचीव्ह सक्सेस या यूट्यूब चॅनलमध्ये आपल्या सर्वांचं स्वागत करतो. आपण MPSC आणि UPSC मध्ये मॅथ्स ऑप्शनल सब्जेक्ट जर आपण विचारात घेतला तर मॅथ्स ऑप्शनल सब्जेक्टमध्ये आपल्याला 2 पेपर बघायला मिळतात. पेपर नंबर 1, पेपर नंबर 2. प्रत्येक पेपर 250 मार्कांचा असतो. त्याच्यामध्ये पेपर नंबर 1 मध्ये असणारा ऑर्डिनरी डिफरन्शियल इक्वेशन खूप महत्त्वाचा टॉपिक आहे, कारण का त्याच्यावरती आपल्याला 40 ते 50 मार्काचे क्वेश्चन्स विचारले जातात. आणि याचा जर विचार केला तर तो 20% फर्स्ट पेपरमध्ये 20% आपलं वेटेज ठेवतो. आणि त्या पेपरमध्ये आपल्याला ऑर्डिनरी डिफरन्शियल इक्वेशनचा जर विचार केला तर फॉर्म्युलेशन ऑफ ऑर्डिनरी डिफरन्शियल इक्वेशन, त्याच्यानंतर त्याच्या वेगवेगळे टाईप्स, त्या वेगवेगळ्या टाईप्समध्ये आपण जर विचारात घेतलं तर आपल्याला ऑर्डिनरी डिफरन्शियल इक्वेशनचा फर्स्ट टाईप आपल्याला बघायला मिळाला तो म्हणजेच काय फर्स्ट टाईप आपल्याला बघायला मिळाला तो म्हणजेच काय तर व्हेरिएबल सेपरेबल फॉर्म, त्याच्यानंतर होमोजिनियस डिफरन्शियल इक्वेशन, नॉन होमोजिनियस डिफरन्शियल इक्वेशन. त्याच्यामध्ये आपण केस नंबर 1 बघितली, स्मॉल ए डिवाइड बाय कॅपिटल ए इज नॉट इक्वल टू स्मॉल बी डिवाइड बाय कॅपिटल बी. सेकंड केस आपण बघितली, स्मॉल ए डिवाइड बाय कॅपिटल ए इज इक्वल टू स्मॉल बी डिवाइड बाय कॅपिटल बी. आता त्याच्यानंतर आपण लिनियर डिफरन्शियल इक्वेशन बघितलं. लिनियर डिफरन्शियल इक्वेशनचा एक फॉर्मॅट बघितला, dy बाय dx इज इक्वल dy बाय dx प्लस p into y is equal to q. P and q are the functions of x that at that time it is called as a Leibniz equation, and this Leibniz equation we can solve by using method of integrating factor. That means integrating factor is equal to e raised to integration p dx, and by using this we have to calculate the solution of linear differential equation, like y into e raised to integration p dx is equal to integration q into in e raised to integration p dx plus c. By using this equation we follow, or we can find out the solution of that differential equation. Right now we are going with the fifth type, and fifth one type, let us consider. Okay, type number 5. Type number 5 is there, and it is a Bernoulli equation. Bernoulli equation. Sorry. तर बघा, आपल्याला बर्नॉली डिफरन्शियल इक्वेशन किंवा बर्नॉली इक्वेशन आपल्याला बघायला मिळतं. जनरल फॉर्म ऑफ दिस वन इज द जनरल फॉर्म ऑफ differential equation. Differential equation is dy by dx plus py plus q is equal to q into y raised to n is here. Just only one change in a linear differential equation or Leibniz equation is what here y raised to n. Y raised to n is an extra factor inside the Bernoulli equation. Okay, so we know that dy by dx is dy by dx plus py is equal to q. At that time p and q are the functions of x. Here p and q are functions of x called Bernoulli's equation. Okay, right now this Bernoulli equation can be converted into when we put n is equal to 0. N is equal to 0. At that time this equation becomes a linear equation. This equation becomes linear equation. How it is comes when we put n is equal to 0 here, n is equal to 0 is here, then y raised to 0, that means it is equal to 1, and then equation comes into the linear equation, or it is also called as Leibniz equation. Leibniz equation is there. Okay, so when n is equal to 1, second part is n is equal to 1, at that time it is a variable separable equation. Variable separable equation. Okay, and when we use n is equal to other than this, that means greater than 1, or it is a 2, and so on, then it is a non-linear 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 equation. Then how to solve that equation? For this purpose, divide both side by y raised to n. Divide on both side y raised to n. You will get what? 1 divided by y raised to n into dy by dx, plus you will get the p divided by y raised to n minus 1 is equal to q. Right now we just shuffle out it, and you will get the y raised to minus n into dy by dx plus y raised to 1 minus n into p is equal to q. How it is? Y raised to n, which is present inside the denominator, we take into numerator. At that time its index is taken as a minus. Similarly, y raised to n minus 1 taken into the numerator, at that time its index becomes a minus. That means minus n minus minus plus 1, and therefore 1 minus n into p in p sorry, p is equal to q is there. Then we put z is equal to y raised to 1 minus n. So we have to take the derivative of z with respect to y, derivative of z with respect to x, sorry, and you will get the consideration of dz divided by dx is equal to 1 minus n into y raised to 1 minus n minus 1 into dy by dx is here, and one cancel to each other, and then you will get the dz divided by dx is equal to 1 minus n into y raised to minus n into dy by dx. So you transfer this value on the other side, you will get the y raised to minus n into dy by dx is equal to 1 divided by 1 minus n into dz divided by dx, and put this value in this equation. Let consider this equation is equal to 1 and this equation is 2. Put in 2, we get y raised to minus n into dy by dx. The value of this is nothing but a 1 divided by 1 minus n into dz divided by dx is here, and y raised to 1 minus n is equal to z, and therefore plus p into z is equal to q. P into z is equal to q is here, and right now we just multiply 1 minus n on both side. You will get the final result is nothing but a dz divided by dx plus 1 minus n into p into z is equal to 1 minus n into q is here. Sorry, and this equation, it is nothing but a linear differential equation in the form of z, and therefore you can solve it by using a linear equation or Leibniz equation formula, or solve formula like that. We know about that is dz divided by, sorry, we know about dy by dx plus p into y is equal to q. Then you have to get the integrating factor is here. It is e raised to integration p dx, and by using that integration factor, y into e raised to integration p dx is equal to integration q into e raised to integration p dx into dx plus c, and this is your final result for that differential equation, that means linear or Leibniz differential equation. By using same concept for this equation, we find out the differential equation, this differential equation in the form of z. Okay, then we know about that z is equal to y raised to 1 minus n is there, and by using this you can solve the complete Bernoulli equation and you will get the final result of this one. Okay, this is your theory for solving the Bernoulli differential equation. Right now we are going with one example related with that Bernoulli differential equation. Then we go through different another type related with the differential equation. Okay, we now solve this differential equation, which is nothing but cos x into dy by dx minus y into sin x is equal to y cube into cos square x. First of all, we have to divide by cos x on both sides. That means you will get what? Dy by dx is dy by dx minus sin x divided by cos x. That means you have to get the tan x into y is equal to cos x into y raised to 3. That means you have to compare with dy by dx minus plus p into y is equal to q into y raised to n. Here n is equal to 3. That means it is a Bernoulli equation. So right now this Bernoulli equation we have to solve it. This is the Bernoulli equation. So first of all we divide by y cube on both sides. You get what? 1 divided by y cube into dy by dx minus tan x divided by y square is equal to cos x is here. Okay, that means y raised to minus 3 into dy by dx minus y raised to minus 2 into tan x is equal to cos x is here. Right now we have to put z is equal to y raised to minus 2. Z is equal to y raised to minus 2. Then taking the derivative with respect to x, dz divided by dx is equal to minus 2 y raised to minus 2 minus 1 into dy by dx is here, and dz divided by dx is equal to minus 2 y raised to minus 3 into dy by dx. Minus 2 is multiply here and it is taken as a divide. Therefore you will get the minus 1/2 into dz divided by dx is equal to y raised to minus 3 into dy by dx is here. So putting this value inside this equation, let us consider once again it is equation number 2 and it is your equation number 1 is here, and now putting those values inside the equation 2, equation 2 becomes okay, what is the putting? Here is the putting, and this putting y raised to minus 3 dy by dx is equal to minus 1/2 dz by dx, put it here, and then y raised to minus 2 is equal to z. You will get the equation minus 1/2 into dz by dx minus tan x into z is equal to cos x is here. Okay, this is your equation. Now multiply on both side by minus 2. You will get the or minus 2 minus sign is taken common and transfer to another side. You will get the 1/2 dz divided by dx plus tan x into z is equal to minus cos x. Then multiply by 2 here, multiply by 2, we get dz by dx plus 2 tan x into z is equal to minus 2 cos x is here. Minus 2 cos x is here. Okay, and this is your Leibniz equation. This is your Leibniz Leibniz form. Leibniz form, or it is a linear differential equation, and we have to find out the linear differential equation, solution of that linear differential equation by comparing with let you consider it is in a z, and your equation is in the form of y, and therefore here p is equal to 2 tan x and q is equal to minus 2 cos x is here. Minus 2 sorry, minus 2 cos x is here. So first of all we have to find out the integration factor. It is nothing but a e raised to integration p dx. First of all we find the integration p dx easier, and then we have to just 1 second, integration p dx, and this is nothing but a 2 into tan x into dx. It is equal to 2, it is a common, and tan x into dx, and therefore 2 into what is the integration of tan x? Integration of tan x is a log sec x is there, and therefore 2 into log sec x. Sec x. 2 is a multiply here. It is a taken as a index here, and therefore log sec square x is there. And this is your integration p dx. Then we have to find out the integration factor. So integration factor is here. Integration factor is e raised to integration p dx, and therefore you have to put e raised to log of sec square x, and therefore integration factor is equal to sec square x is here. And by using this sec square x in x is in a general solution, and we had to get the general solution. The general solution is z into e raised to integration p dx is equal to integration q into e raised to integration p dx into dx plus c is here. And we know about that integration factor, that means if is equal to e raised to integration p dx, and we have to put it here z into sec square x is equal to integration. What is the value of q? Q is nothing but a minus 2 into cos x into sec square x into dx plus c is there. And then we're taking minus 2 outside the integration, and cos x into sec square x means 1 divided by cos square x into dx plus c is there, and therefore minus 2 into cos cancel to each other, 1 divided by cos x into dx plus c is there, and therefore you will get the minus 2 into integration of sec x into dx plus c, and here z into sec square x into sec square x is equal to minus 2 into log of sec x plus tan x plus c is there, and z into sec square x is there, and this is your final solution of that Bernoulli equation is there. जर समजा तुम्हाला हे आवडलं असेल तर व्हिडिओ शेअर करा, लाईक करा, शेअर करा आणि सबस्क्राईब करायला विसरू नका. थँक्यू.